All right, so here we go. The last question that we're going to look at today, and this is it. So this one gives us a random variable t modeled by a Poisson distribution, and we're given that the probability of t being greater than 2 is 0.53, and it asks us to find the variance of t. Now, the variance of t, remember, is the same as for Poisson distribution, is the same as the expected value, which is also the same as that parameter that we have for the Poisson distribution. Now, this one, remember with the binomial distributions, it was a little bit more tricky if we needed to find that parameter. Kind of in the binomial, it was if we needed to find the number of trials, right? In this one, finding the parameter is a little bit more tricky. Now, as I mentioned in class, remember, because the calculator and because our function is actually a continuous function, we can actually use a graph here, and that's my hint, is that we can use a graph in order to be able to solve this one. All right, so that's actually what we're going to do. We're going to switch over to a graph here. Okay, now it does say that the probability that t is greater than 2 is 0.53. Greater than 2, we remember, has that issue of having to go up to a really big number. I'd rather avoid that if I can. So instead of doing greater than 2, I'm going to do 2 and less, which means I'm going to use the opposite of 0.53. All right, so the first thing I'm going to do, I'm going to set up the Poisson. So Poisson, this is going to be a CDF because I'm going to use a parameter of x, and then I'm going to go from 0 up to 2, right? And I guess you could put 1 minus that if you wanted. There's a variety of different ways, but I'm going to do Poisson CDF with parameter of x going from 0 to 2. Okay, that would be the opposite of this, so that would be everything 2 and less. All right, so I push enter, and you see it gives me a nice little graph down there. I may try to zoom in a little bit later if I really feel like it. The second part of the equation is going to be the right-hand side. Now remember, I did the opposite of this, and so instead of 0.53, I'm going to put 0.47. Okay, and so once I do that, then I should be able to push enter. It gives me that graph as well. So you can see that there is a place where they intersect down here. And I'm going to actually, let's see, can I move this label a little bit so that it's out of the way? And just for the fun of it, just because I think it's important for us to get used to this, we're going to go to Windows Zoom, and we're going to zoom in a little bit. I'm going to try to zoom in right there on the intersection. So I'm going to put my magnifying glass there, and you can get this by taking your finger and rubbing over the sketch pad, and then the cursor should appear, and you should be able to just kind of say, I want to zoom in on the center, and that's good enough. I can still see the x and y axes. I should be able to find that intersection now. And the intersection, of course, I'm going to go into menu, then I'm going to go analyze graph. Once I analyze the graph, then I'm going to find the intersection. It says lower bound right here in the bottom, so that means I need to go to the left of the intersection. And then upper bound, I'm going to go to the right of the intersection, and lo and behold, there it is. I'm going to move it so I can see it a little bit better. You can do all this on your calculator, so I get an answer of 2.8 comma 0.47. Now we knew that the y value was 0.47 because that's the red line here, right? That was the number that we needed over there. But this first number, x, is the x parameter, because remember when I did the Poisson, I put in x, and so the x value is what I'm looking for, 2.8. So therefore 2.8 is the parameter of this Poisson distribution, and given that 2.8 is the parameter, that means that 2.8 is also the variance, and so that's your final answer, is that the variance of t is equal to 2.8. No problem. All right, that's it for today.